Gallagher from Veritas Education, and this is the Troubleshooting Netbackup Deduplication lesson. In this lesson, we'll take a look at Netbackup deduplication, how it works, and take a detailed look at the process flow. We'll talk about how to maintain and troubleshoot MSDP pools, and we'll finish up by taking a look at protecting the MSDP catalog. We'll begin with an overview of how Netbackup deduplication works and a look at the deduplication process flow. Deduplication is the elimination of redundant data from backup storage. Deduplication uses a hash algorithm to provide data with a unique identifier, and that algorithm provides the ability to prevent the data from being stored multiple times while still allowing the data to be restored when necessary. These algorithms produce what's usually referred to as a fingerprint for each individual piece of data. And deduplication is a major transformative technology for disk backups. It's a key enabler, really. Folks that have always wanted to do backup to disk but never had the space to do it before are now able to do it because of deduplication. Or maybe the consideration is, I never had enough room on my disks for the retention that I wanted. And now, because dedup is so much more space efficient than regular disk storage, now I can keep data, for a month or so locally on disk before I archive it off to tape. And so we see the disk transforming from being more of a temporary staging area to being a longer-term storage for my data. Maybe not longer term like multi-year retention, but maybe long enough that my main point of disaster recovery is all coming from disk instead of from tape. And so it's pretty much a guarantee that anybody who's doing backups to disk on any scale is either using dedup technology or seriously considering it. It's a tremendous advantage. Now, one of the things that we think about when we do dedup is where will this dedup take place? Will it take place at the source or at the target? And what are the pros and cons to both? We'll take a look at that in this topic. Now, Netbackup provides several places where deduplication can take place. Dedup can happen with either MSDP pools, pure disk pools, or OST pools. Now, we mentioned already pure disk pools are at this point a legacy product, which is still supported in the case of the 5030 appliances, but it's not a solution that's really being sold anymore. Pure disk was a whole separate product that was acquired by Symantec. And in way old versions of Netbackup, back in 6.5, if you wanted to have deduplication, you would set up one of these pure disk pools, and it was a whole separate backup product, really. And Netbackup had the ability to export data to pure disk to be deduped. Pure disk had the ability to send data to Netbackup to do a tape out. There were hooks. The two products worked together because they were owned by the same company, but you could still tell you were running two different applications. And so the big thing that was missing, that we needed was to integrate this stuff, make it an organic part of Netbackup and not two separate things that talk to each other. And that's what happened with MSDPs, starting with version 7. An MSDP, Media Server Deduplication Pool, has got these pure disk services running natively on Netbackup media servers, so that the ability to create dedup pools is organic. MSDP pools originally had a lot less capacity than PDDO did, so the pure disk pools were still a part of Netbackup for some time until the MSDP kind of caught up, and so now in the appliance form factor you can have much larger pools than you ever could with PDDO. The maximum PDDO ever got in the appliance form factor, you could take 6 5030 appliances and chain them together for 192 terabytes. Whereas the Netbackup 5330 appliances are capable of managing 1/4 petabyte of data. And it's very scalable. Netbackup appliances are available in different sizes, to scale to your needs, anywhere from 4 terabytes to 1/4 of a petabyte. It's very adjustable. And any conversation about dedupe these days does tend to steer us towards appliances, and that's because appliances are an extremely effective way of bringing dedupe to your environment. Instead of setting up and managing one of these dedupe pools yourself, you can kind of drop an appliance in place and it's a turnkey solution. There's a brief configuration and setup that you do, and then you're ready to go without a lot of tuning and without a lot of worries about hardware compatibility. Because one thing about dedupe is it's a very demanding task for your disks. And if you're going to make it yourself MSDP pools, you want to make sure you have fast, high-performance disks, which can sustain a good transfer rate. We've seen a lot of problems, Netbackup support, with corruption of data in pools, all due to the disks not being able to sustain a good transfer rate. Appliances are nice because they eliminate that. The integration, testing, compatibility, and speccing out of these disks is all done for you. The appliances are designed from the ground up to give good dedupe performance. So Netbackup appliances are a great way of using MSDP in your environment. As we've mentioned before, we don't just support Netbackup appliances, we support appliances from other vendors as well. Data Domain, Greenbytes, Cepiton, Exagrid, Falcon Store. There are HP, there's a number of OST partners, and their appliances are compatible with Netbackup through OST. And just about any appliance these days is going to support, at a minimum, dedupe. And probably it supports a bunch of other things as well. Again, the hardware compatibility list will give more detail on that. Here's an overview of how Netbackup deduplication works. Netbackup does inline dedupe as data is coming in. And so for each file in the file system, Netbackup is going to take a look at the file, and it's going to separate the file metadata from the actual contents. The actual contents are going to get broken up into chunks of data referred to as segments. Segment size by default is 128 kilobytes in Netbackup, although this will vary because the end of a file is always the end of a segment. And so you may get some smaller segments, when you have smaller file sizes. And so Netbackup is going to go through and analyze each one of these segments. Basically, it's going to do a hash on the segment, and that produces a fingerprint. The fingerprints are stored with the data in the MSDP pool. So when the backup runs, unique data is written to the MSDP pool, and the fingerprints are stored in the fingerprint database, which is part of the MSDP pool. Unique data only needs to ever be written once. And so in this example here, file number 1 had 4 segments, A, B, C, and D. This is all new stuff. This is basically, we started out with an empty pool, so all 4 segments got written to storage. Now we move on, file number 2. Separate the metadata from the data and analyze the file. And when we bust up this file into segments, we see that a lot of the segments, half of them, are ones that we've already protected. That particular data was part of this other file that we backed up before. There's no need to back it up again. Only the unique stuff is protected. And so in this example, we have only written 6 segments of data to disk. However, the dedupe engine can restore either one of these 2 files. We're protecting 8 segments of data using 6 segments of disk space. And this is a very, very small example of how dedupe works. Of course, when you think about it, each one of these segments, 128 kilobytes in size, on an enterprise scale disk that we'd be protecting, we'd be talking about hundreds of thousands or millions of these segments. And there is a tremendous potential for storage. Regular file system backups tend to produce excellent deduplication rates, particularly when you think about just the way we protect data. You run a full backup of data every week. What are you really doing? What's your change rate? 10%? Well, that means 90% of the data that you're backing up every week isn't actually changing. Why write it all to disk again? Let's just capture the changes. And then that applies to data between servers as well, because a lot of times there'll be identical data on different servers. Everything that goes to the same dedupe pool gets deduped against each other. to eliminate this redundancy. And it is the dedupe engine's responsibility to be able to produce either of these files on demand, a process which is referred to as rehydration. Rehydration is when we reassemble segments into files. It happens during restores, and it happens during duplication to targets that don't support dedupe, like a tape out. Here's a look under the hood at what happens inside an MSDP pool. When data is being protected, data is going to get handed off from the Netbackup BPTM tape manager process through the OST interface to a dedupe plugin. And the dedupe plugin is provided by Veritas, but it is very similar to the third-party plugins that are associated with OST, same interface that we're using. And from the dedupe plugin, data is sent to the dedupe engine. Metadata is sent to the catalog. The dedupe engine, which is spool-D, is the name of the process, is the one that does the actual deduplication of the data and does the actual writing of data to the storage path. The other major process that's associated with MSDP, SPA-D, is the deduplication manager, and that's more of a boss process that does administrative stuff like handling replication. Now, the data and metadata can be, and usually will be, written to different paths. And so the storage path shown on a slide here has the actual data, the segments. The database path has the metadata, the fingerprints are all stored in here in the dedupe database. When you do a build-it-yourself MSDP pool, you will usually have one volume for storage and one volume for the database. In recent releases of Netbackup, we have allowed multiple storage volumes to allow for greater size of MSDP pools. MSDP pools can, the build-it-yourself pools can get up to 96 terabytes in size. You can only go higher than 64 on Linux. So that's Red Hat and SUSE lets you go up to 96, and in that case you'll have multiple storage volumes. Netbackup appliances allow you to go considerably higher than that, up to 144 terabytes with the 5230s, or 229 terabytes with the 5330s. And we can sustain much larger dedupe pools on appliances compared to build-it-yourself MSDP pools because Veritas controls all the variables. We don't have to worry about, is this a SAN disk or an internal disk or an iSCSI disk? What's the performance? What's the throughput? How many IOPS? What kind of RAID controller are they using? We know the answers to all those questions. We built it, and we've optimized the hardware to support a pool of a certain size. And so that's another reason why appliances come into the conversation a lot when you talk about dedupe pools, because they can scale bigger than build-it-yourself pools can. Here's some detailed examples of how deduplication works in Netbackup. We'll begin with media server deduplication, or target dedupe, which is the default behavior for MSDP pools. The client is going to send all of its data across the network to the media server, same as it normally would. Data is going to get passed to the dedupe plugin, where it's going to be segmented, fingerprinted, and unique segments are going to be identified, and then the unique segments only are going to be written to storage. Here's a detailed backup process flow when we do media server dedupe. And so the job is initiated by the scheduler as usual. It's the job manager NBJM process that'll be actually running the job on the master server. The master server reaches out to the media server and starts the BPBRM process, the backup and restore manager. Backup and restore manager will first connect to the client to make sure it's available, and if it is, it'll start the BPTM process. So far, by the way, nothing is different in this job than about any other job, that we covered in previous lessons. Where it starts to get different, the BPBICR process sends data to BPTM. BPTM, instead of writing the data directly to tape or disk, as it would with other storage options, is going to send the data to a dedupe plugin. The dedupe plugin is responsible for analyzing that data and communicating with the dedupe engine to determine what's unique and what's not. So the dedupe plugin segments the data, fingerprints the data, compares the information with the information that it's getting from the dedupe engine about what's unique and what's not. Unique stuff only gets forwarded to the dedupe engine. Unique stuff only gets written to storage. And there is still, in this case, a second connection from the client. BCAR is sending the metadata, the paths that are being protected, to the backup and restore manager on the media server. The media server is forwarding that data to the database manager on the master server. That part is no different than it would be for any other backup job. And note that the records in the image catalog are still going to have the complete list of files that are protected, even though in actuality we may only have written a small percentage of them. We're still tracking that they're all there. Now, dedupe involves a lot of math as we go through breaking these files into segments and then using a hash to analyze and fingerprint each segment. And so to prevent this fingerprint hashing workload from overwhelming a media server, we provide the option to use load balancing media servers. And that means essentially you have one MSDP pool with multiple media servers associated with it. One of them will be the storage server. The other ones will be the load balancing media servers. And so clients can send their data to any of these media servers. They can send it to the storage server or to one of the load balancing media servers. And that's not something you have to configure. That's automatically done by Netbackup using its load balancing algorithms. Netbackup will take a look at which of these media servers are working the hardest, and it'll choose the one with the lightest load for each particular client as it goes active. And so if the client sends data to the storage server, well, then it gets deduplicated and written to disk by the storage server. If the client sends data to the load balancing media server, the load balancing media server communicates with the storage server to identify what's unique and what's not. The unique stuff only gets sent across the network to the storage server. The storage server writes it to disk. Remember that it is always the storage server that has exclusive write access to the disks themselves. The load balancing media server send their data through the storage server. Now let's take a detailed look at the process flow for load balancing media servers. The job is going to be initiated much the same way as normal. The job manager reaches out to the media server, and in this case, there's already been a resource allocation, and as part of that process, there are multiple media servers that are associated with this dedupe pool, and the Netbackup EMM services have determined which one is the best one to use. And that's because the media servers report their status to the EMM services on the master server periodically. And so Netbackup is looking at RAM usage and CPU utilizations and just generally how hard these servers are working. So there's already been a determination that for this particular client's data, this client is going to send its data to the load balancing media server for this particular backup job. Next week, might go to a different media server. It doesn't matter. It's all going to the same pool eventually. But tonight, this is the server we're going to use. So job manager reaches out to the media server, starts the BPBRM process. BPBRM starts the tape manager. The BCAR process on the client sends all of the client's data to the tape manager process. The tape manager passes it along to the dedupe plugin. Now the dedupe plugin is responsible for deduplicating this data, for fingerprinting it, and for deciding what's unique and what's not, and sending along the unique data only to the dedupe engine. That's a transfer that'll happen across the network, and then the dedupe engine writes it to disk. So note that load balancing media servers never write directly to the disk, only the storage server can do that. And then there's, as usual, a second connection from BCAR on the client to BPBRM on the load balancing media server. That's the metadata, the paths that are being protected. That goes from the media server to the database manager and into the image catalog on the master server. One decision that we'll make when we're configuring deduplication in Netbackup is whether to have the dedupe happen on the media server side or the client side. And another way of saying this is, do I want to do source dedupe or target dedupe. Normally, dedupe happens as target dedupe. The client sends all of its data to the Netbackup media server. The media server figures out what's unique and what's not. Then the unique stuff only gets written to disk. So I get the advantage of this big space savings on disk and a lot less data moving across the storage network, but I still have the client pushing all this data across the LAN to the media server. When I switch over to client-side dedupe, it means that there's a plugin installed on the Netbackup client, which is there automatically. I don't need to manually install that. And the client is going to analyze the data, and it's going to communicate with the media server to determine what's unique and what's not. And it's going to send the unique stuff only across the network to the media server, and then of course unique stuff only gets written to disk. Client-side dedupe is an improvement because it means that in addition to the space savings on disk, I'm using a lot less network bandwidth between the client and the media server, and in many cases that network is a big bottleneck for backup performance. It also means that in terms of all of this math, the fingerprinting and analyzing of data, instead of having the backup servers do it exclusively, I'm spreading it out. Each client does its own little bit. And that, kind of illustrates the pros and the cons. Lots of advantages, especially in terms of network bandwidth consumption. It does mean that the client is doing some extra work during the backup window, and I have to think about whether that's, appropriate or not. If this is already a heavily burdened server, I might say, I don't want to give this server one more extra thing to do. I don't want to do anything that will increase my backup footprint even by a little bit. This is already a very busy, high-value production server, and that's fine. So I can use target dedupe for those servers. And for servers that have some CPU cycles to spare, I can use source dedupe, client dedupe for them. And you need to look at this in terms of the big picture. The knee-jerk reflex is, anytime I say more processing on the client, I get very nervous about that. After all, these are production servers. Totally understand it. But if I switch from target dedupe to client dedupe, and my backup job now takes half an hour to run instead of taking 3 hours to run, in the big picture, have I really increased or decreased my footprint? I've probably made things better. So you need to think about it. It's a good choice for many clients. It's certainly a great choice for WAN clients because it's so bandwidth friendly. And in many cases, it's going to be a very good choice for LAN clients as well. It'll really improve overall performance. But it's not for everyone. And, Netbackup is very flexible. You can choose whether on a per client basis, whether to do target dedupe or client dedupe. So some servers can dedupe at the source, and others, the media server will do it. No big deal. It's so flexible, you can even set it up in Netbackup so that you've got 12 clients on a policy, and half of them do media server dedupe, and the other half do client dedupe. No problem. The next process flow shows client-side deduplication, and this will be different than media server deduplication in a number of respects. The creation of the job happens in a standard manner. Job manager reaches out to the media server, starts BPBRM. BPBRM starts the tape manager. On the client, things happen a little differently than usual. In BPBCAR, instead of sending data directly to the tape manager, the way it normally would for every other kind of backup, BCAR is going to hand this data off to a process called NBOST proxy. NBOST proxy is able to communicate with the proxy plugin on the media server. And it's going to work with the dedupe plugin on the client to segment the data, analyze it, and determine what's unique and what's not. The unique data only is going to be sent from the dedupe plugin to the dedupe engine on the media server, and then from there to disk. Note that NBOST proxy is talking to the proxy plugin on the media server, and at the very beginning of the backup, the client is receiving a cache of fingerprints to work against. And that cache is made up of all of the files from the last full backup of this client, at least all the fingerprints for those files. That way, let's say there's 100,000 files in the file system. The client, you don't want it reaching back to the media server 100,000 times to say, is this new? How about this? Is this different? How about this one? You give the client a cache of fingerprints to work off of, and if it gets a cache hit, it knows that this is not unique data. It doesn't need to send it. If it gets a cache miss, then it says, all right, this seems to be unique. We'll double check with the dedupe engine just to make sure that maybe some other client didn't back this up at another time. And as long as it truly is unique, then and only then will I send it across the network and to the media server, and then it gets written to storage. The metadata still gets sent via a second connection from BCAR to BPBRM, and then up to BPDBM on the master server to go in the image catalog. So you can see where this is an extremely network-friendly solution. It's unusual because we've got this plugin on the client, and normally you never have OST plugins on a Netbackup client. Those get installed on the media server. This is the one and only exception to that. And that means that Veritas's dedupe solutions, MSDP pools and Veritas appliances, are the only solutions that support true client-side dedupe. Here's an example of a restore process flow. The restore is handled the same way as a standard restore in Netbackup. So on the media server, we have the same players involved, BPBRM and BPTM. On the client, we have the tar process that's ultimately going to be receiving the data. The difference comes in the retrieval, the reading of the data. The BPTM process, instead of reading the data directly, is going to reach out to the dedupe plugin and request the data from the dedupe plugin. Hey, somebody asked me to restore these 100 files. Please give them to me. The plugin is responsible for communicating with the dedupe engine and saying, here's the files I need back, where the dedupe engine has to get the segments that make up those files, reassemble them, provide them to the plugin. The plugin provides them to BPTM, and then at that point BPTM streams the data to the tar process on the client, same as any other restore. Here's a description of the optimized duplication process flow. Now, as a reminder, optimized duplication, or updupe for short, is an OST function that allows a storage server to duplicate data directly to another storage server. That's an updupe. And so this might be a storage server that's a media server. In the case of an MSDP, it might be an appliance. You might have an updupe where the appliances are duplicating data directly between them without going through a media server. In most cases, dedupe will be a part of this, because just about anybody who's doing an updupe these days, anybody's pool or appliance, will usually support deduplication. And that's what's going on in our example here. And so when deduplication is in the mix, if the source and the target storage servers are compatible dedupe storage servers, then only the changes are going to get sent. So if I updupe a full backup from one MSDP to another MSDP, only the changes go since the last full backup, not the whole image. A lot of vendors will refer to this as a replication, although in Netbackup, when we say replication, we're usually talking about the the auto image replication functionality between Netbackup domains. Whereas when we talk about activity within a domain, we usually use the term updupe, or optimized duplication. So, here's what happens. The job manager requests the dedupe engine to run an updupe job. The mini spa, in other words, the deduplication manager, starts an updupe job by determining the destination type, making sure that it's compatible, locating the image, communicating with the target storage server to determine which are the unique segments that need to be sent, and then sending the unique segments, and then updating the remote catalog. While this is all going on, the Netbackup job manager is polling the dedupe manager to see when the job is finished. Other concepts that are important with dedupe pools, you may hear the term stream handlers, and that's for Veritas-specific pools, MSDP pools. Stream handlers are a way of processing the data as it comes in to improve dedupe rates. And there are stream handlers for a number of different types of data types, such as regular file system backups, system state, virtual machines, NDMP. What's going on here is some intelligence. Veritas has an advantage over other vendors in that the data is passing through our processors at every point from end to end. And so the whole data stream, file boundaries, file and metadata is all visible to our processes. And so if there is a possibility along the way to improve dedupe rates by processing the data differently, that's what a stream handler will do. And so, for example, the simplest thing is identifying file boundaries, so that the end of a file boundary is always the end of a segment. Dramatically improves file system dedupe rates, and so that happens automatically when you dedupe file systems. It also means that the same file on different types of storage, like for example the same file on a virtual machine being backed up with a VMware policy, and also on a physical machine being backed up with a standard policy, they're going to still dedupe against each other, as a stream handler's process as well. For some data types like NDMP, which traditionally used to get terrible dedupe rates, we found through testing that if we strip the tar headers from the data in the NDMP stream and send the tar headers separately from the rest of the data, suddenly dedupe rates get much better. So that's something that our stream handler does. So the long and short of it is, anytime you see, hey, this new version of Netbackup has a new stream handler for such and such a type of data, well, if that's data that you're protecting, you want that. It's going to tremendously improve dedupe rates. Unrelated to stream handlers, the second point on the slide here, there's some additional port usage when you have dedupe functions. If you have media server load balancing, optimized duplication, replication, or client dedupe, those are functions that use pure disk ports, 10082 and 10102. You want them open for bidirectional TCP between load balancing media servers, between updupe or replication targets, or between clients and media servers if you're doing client-side dedupe. If you're doing regular media server dedupe, you don't need these ports. If you're doing client-side dedupe, you do. In the next topic, we'll discuss maintaining and troubleshooting MSDP pools. There are multiple points to gather information about your MSDP pools within Netbackup, the same reports that we've seen for other types of disk pools. The disk reports in the admin console, the device monitor, the disk pools and storage server properties, as well as commands like nbdevquery from the command line, the opcenter interface, all have great reporting capability for giving you information about your dedupe pools. Another point of collection for MSDP pools is the storage server properties. The Pure Disk storage server, if you right-click on it and select its properties, gives you information about the storage server and the dedupe pool that it controls. Some of these are values that you can change, like the logging level. A lot of it is really just read-only information. The topic of reclaiming MSDP storage space can be complex to understand. The key thing to remember is that dedupe uses your disk space much differently than other types of disk storage does. If I have a basic disk storage unit and I back up a 100 gigabyte image, how much disk space am I going to need? 100 gigs. And let's say this image expires in 2 weeks. How much space is going to be freed up? 100 gigs. Very predictable. Well, let's say I take a 100 gig image and I back it up to an MSDP pool. How much space am I going to need? I don't know. Is this all unique data? I might need the full 100 gigs. But if some of this data is not unique, I'll need less. I really won't know until I do it. And let's say that this is a regular backup I'm doing once per week. When a particular backup image expires, how much space will be freed up? Well, I don't know. Just the unique bits of that image, aren't needed anymore and can be deleted. But a lot of the data, the static data that's not changing, is not going to be able to be deleted because it's supporting other backups that I have taken since then. So again, I don't really know until later on. So to get any kind of good information about space utilization in dedupe pools, you must use the Netbackup provided reports and interfaces. Do not attempt to use OS commands like Windows Explorer or DF because that route leads to madness. Dedupe uses space very differently. The other thing that MSDP pools do is that they don't write individual segments directly to disk. The segments are organized into container files, which have a default size of 256 megs in a build-it-yourself MSDP configuration. And so that means that data gets tucked into these container files, and we do that so that we don't litter the file system with millions and millions of teeny tiny files that would degrade overall file system performance. And internally, the dedupe engine is tracking available space within the container files, and so when images expire, it'll free up space within the containers. But again, if I were to just look at the file size from the command line, a whole bunch of stuff might expire and space might be freed up, and I'd never see it in like Windows Explorer. It's just internally the dedupe engine knows it now has more space available. So for that reason, I must use dedupe aware commands. Some good examples here on a slide. NBDev query is dedupe aware. That's at the disk pool or the storage server level. CR control, which talks directly to the dedupe engine. That's another way of getting dedupe aware reports. The reports in the admin console are aware of this behavior, as are the reports in Op Center. Now, what if I did want to try to free up as much space as possible, as soon as possible? I'm worried about whether tonight's backups will run successfully or not. It's best usually to allow the dedupe pools to do their own housekeeping automatically. As noted on the slide, MSDP queue processing takes place every 12 hours. Queue processing means that the dedupe pool is going through and processing the queue for deletions, and that's the removal of data that doesn't need to be there, for example, expired images. And so it's kind of a two-step process to free up space within a dedupe pool. Netbackup sends a signal to the dedupe engine, says, hey, this backup image has expired, it doesn't need to be there anymore. The deletion notice gets added to the queue, and then the queue gets processed, and segments which don't need to be there anymore are identified and are deleted from disk. So what this means is there is a delay. If you just run BP expedite on a image in a dedupe pool, space is not instantly freed up the way it would be in, for example, a basic disk storage unit. Instead, it happens during queue processing, which is part of the housekeeping processes for MSDP pools. And it typically takes 2 cycles of queue processing to expire a backup image and to get the space back. So if I was very worried about space, if I wanted to immediately free up as much space as I could, CR control -- process queue, I would run the command twice, and whatever space there is that can be freed up, that'll free it up for me. Just be realistic in your expectations. Again, remember, even if I delete a backup image and then I run CR control and process the queue twice, I'm not likely to free up an enormous hunk of disk space right away. I've probably got multiple versions of that backup image, and there's probably dependencies. Some of that data probably needs to stay there in the pool to support later backup images. I'm only going to see an enormous free up of space if I do something like delete every backup there is for a particular client or something like that. Here's some example of some dedupe-aware reporting tools in the admin console. So under disk pools, just by checking out their properties from there, that's the equivalent of running the NBDev query -listdp from the command line. Either way, dedupe-aware reporting. Or another example of something we showed you on a previous slide, checking the properties of the storage server itself, also gives up-to-the-minute statistics on space utilization within that pool. Here's some disaster recovery considerations when working with dedupe disk pools. The biggest thing to think about is the old saying, if I've only got one copy of my data, it doesn't exist. So the first step is always making sure I have multiple copies, and updupe or replication is a great way to do this. Use storage lifecycle policies to either updupe or air your data to another disk pool And that will give you copies both of the data and the metadata. When you do updupe or when you do err, you're not just sending the segments, you're sending the fingerprints as well, so that the target disk pool has everything it would need to do a restore. Now that's the traditional disaster recovery method, and that's why dedupe infrastructure is not protected with catalog backups, because that question gets asked sometimes. When I back up the catalogs, do I back up all this MSDP catalogs as well? And the answer is no, not by default. You know, the default method of protecting things is to replicate multiple copies. Now, there has been a request over the years to introduce that capability. So beginning with 761, you can create an MSDP catalog backup policy, and that policy will specifically back up the catalogs for a particular dedupe pool. And so that can give you just another layer of protection. You figure the copies you're making is one level of protection. Dedupe pools have an automatic shadow copy and self-healing capability built in, running all the time, doesn't need configuring. That's a second layer of protection. To add yet another layer of protection, I can use these MSDP catalog backup policies. And that's nice because, you know, maybe what I'm worried about is not just the full DR scenario, but what happens if I just get some really bad corruption in the pool and the pool's self-healing capability doesn't seem to be able to repair it. You know, I can go back to an earlier version. The Netbackup deduplication guide has got steps for a number of different DR considerations, including storage server failure, hardware failure of the disks that make up the pool, or how to recover storage servers after Netbackup catalog recovery. Changing the storage server name or the storage path is possible if necessary. What I would do if I needed to do that was to make sure there's no activity going on, deactivate all the backup policies that target this MSDP, expire the backup images without deleting them. That means using BP expedite with the -no delete option, so the records are removed from the catalog. Then I delete the storage units that target the disk pool, delete the disk pool itself, remove the storage server, and then there's a cleanup script that I can run to delete some of the other little itty-bitty parts of the MSDP pool that will still linger in the configuration even after steps 1 through 5. And so this script, pdde delete config, is a shell script or a batch file. It's platform specific, you know, depending on whether you're on Unix or Windows. That does the rest of the cleanup. And then I can go through and delete the dedupe host configuration file, and I essentially recreate everything from scratch. I change the storage server name or the storage location, whichever one it was that I wanted to change. I run the configuration again as if I was creating a new pool, and I import back in those backup images that I expired. This scenario here is I have a failed storage server, a host failure, but the underlying data is still valid. Maybe it was stored on SAN disks, and so here's how I can recover from that. You'll notice these tips are pretty similar to what we looked at for changing a storage server name or path in previous slides. I start by expiring the backup images with the no delete option. I'm just cleaning out the catalogs. I delete all the objects that reference this pool. So that means deleting the storage units, deleting the disk pool, deleting the storage server, deleting the host configuration file, and if I have any load balancing media servers, I want to delete the credentials for them as well, so that I'm really starting with a clean slate. I configure my new storage server, making sure that it meets the dedupe requirements, and I'm going to be using the same or different host name and the same or different network interface and storage path. You know, it's not completely rigid here. It can be a little bit different than the original. Then I reattach the storage. I make sure Netbackup Media Server software has been installed, and then I can reconfigure dedupe and import the backup images. In this last topic, we'll discuss protecting the MSDP catalog. The MSDP catalog contains critical metadata about the data that's stored in the dedupe pool. So in the storage path within the pool is where the actual data is, the segments. in the database path is where all of the fingerprints are and where all the associations are. You know, where you say, hey, this particular backup image contains these files. These files are made up of these segments, and here's where these segments are stored. Lots of pointers, lots of metadata, all important stuff. You know, in order to do a restore, you need them both. You need the data and you need the metadata. So this is typically a separate path from the backup data. It's typically a separate volume. Usually, even in a build-it-yourself pool, you'll have a separate volume for metadata so that the metadata can be transacted asynchronously from the data. It usually gives you snappier performance. Appliances always do this. In build-it-yourself pools, it's optional but recommended. And this data is not protected by Netbackup catalog backups. And that's because, like we mentioned previously when we were talking about disaster recovery, the traditional protection mechanism for MSDP pools is duplication, opt-dup or error, either which method would move both the data and the metadata to another location. And so I'm protected in case my primary site fails. I would have everything I need, data and metadata, to do my recoveries. But there are other situations that can happen other than, you know, complete destruction of the pool. What if I had just some corruption got into the MSDP catalog? So my data was good, but the metadata is all messed up. And so over different Netbackup versions, Netbackup has added different features to improve the resilience of the MSDP catalog. One thing that's been added is the ability to have shadow copies and a self-healing capability. So the online catalog protection is a shadow catalog. It's shadow copies of the MSDP database that are made periodically. If corruption is detected within the pool, this shadow copy can be used to repair the damage. And there's no, administrator action needed here. You may not even notice there ever was a problem. It just fixes itself. Great. So now we've really got two levels of protection there. We've got whatever duplication or replication we're doing. Now we've got another level, the shadow catalog, that's happening automatically. And then if we wanted one more level of protection, we also have the option in 7.6.1 and later of creating MSDP catalog backup policies. And these are policies that specifically back up the MSDP catalog. So this just gives an extra level of protection. Let's say maybe we do get really bad corruption or something just gets totally messed up in this MSDP catalog. Maybe I lose the whole catalog, and the shadow copies are also for some reason unusable. If I've got backups of it, I can roll back to a known good version and avoid data loss. I can work with support in reconstructing my MSDP pool. So this online MSDP catalog protection runs automatically. It's on by default. There's no action that's needed. It's automatically creating multiple copies of the MSDP catalog metadata using shadow copies and journals. It's stored on a separate directory on the MSDP storage server, and it's used for self-healing of the pool, where corrupted data can automatically be repaired. Now, what they're referring to here is the offline MSDP catalog protection. I don't know if offline is really the best word. They're just trying to emphasize that this is another level of protection that's not turned on by default. You need to go through and activate this if you want to do it. There's a special utility called the DR control utility, which creates an MSDP catalog backup policy for you. So you don't have to go through manually and do it. And mostly the reason for this utility is to make absolutely sure the right stuff is being protected, and the administrator doesn't have to worry about whether they're getting the backup selections right in the policy. So just like on the master server, the catalog backup policies just automatically know where to go to get all the good catalog stuff, same thing is happening here. If you create one of these policies, it'll automatically be configured to find the right stuff. Recovery of the MSDP catalog, if you ever need to do that, is also done using the DR control utility. So if you ever find yourself in that situation, I would strongly recommend getting support engaged to assist you. Here's a closer look at the anatomy of an MSDP pool. Here we see the storage path, which contains the actual data segments, and the catalog path, which contains the deduplication database. And that's all of your metadata and your fingerprints and pointers. And it also contains the structures that are used to provide online protection, the shadow catalog and the journal, the same volume but a different directory than the rest of the deduplication database. And it is those elements, the shadow catalog and the journal, that will be protected if we choose to configure an MSDP catalog backup policy. This slide outlines the steps to create an MSDP catalog backup using the DR control utility. First thing is to configure the MSDP storage server as an additional server in the master server host properties. This gives it the required permission to execute the command. Then on each non-appliance MSDP storage server, we're going to run DR control. We don't need to do this for appliances because it's already been done on appliances. These MSDP catalog backup policies already exist. They're inactive, but they're there. And we're going to run it separately on each storage server, and we're going to have separate policies for each storage server. We're not going to try to combine multiple MSDP storage servers onto a single policy. That's because of the danger of variations in backup selections becoming an issue for us. Now note that all MSDP catalog backup policies, appliance or non-appliance, are inactive by default. I need to go through and activate them. And of course I also need to go into the schedules for this policy and determine when they're going to run and what retention period I want. In this lesson, you learned about how Netbackup deduplication works. We took a look at some detailed process flows. We learned how to maintain and troubleshoot MSDP pools. And we learned about the MSDP catalog and how to configure MSDP catalog backup policies.